Hello, and welcome to the first lecture video of Statistics, Psych 42. What we're going to be covering today is kind of statistics in a nutshell. So what you're able to do with statistics, some of the research methods that are used for statistics. Um, so let's just get into that, but without further ado. Um, boom, shacky. So these PowerPoints are all available to you on Canvas. So if you guys want to watch these videos and follow along with the PowerPoint, that's more than okay. I would encourage that. But first off, what is statistics? It's a branch of mathematics that's used to pretty much analyze, interpret, summarize groups of numbers and observations. So a lot of times people think of statistics as very cut and dry and just like, oh God. And it can be, certainly, but you can also pretty much analyze anything you want to with statistics. So if you're trying to figure out if an egg or a reality TV personality is more likable, you can create a study and analyze the data using statistics, and that information can be generalized to a population. So you can use statistics in really any way that you want to, so long as it's using proper methodology. So there's the quote by Mark Twain that says, "There are lies, damned lies, and statistics." I would like to edit that by saying that there is blindly listening to statistics, willful ignorance, and knowing enough about statistics to recognize the flaws and biases in the findings that are represented. Oftentimes, statistics are just used by media, be it news networks or, I don't know, just any kind of channel that's trying to, sound like to report the public's opinion or something like that. But oftentimes statistics and data can be manipulated in a way that benefits the person that's posting it. For example, there was a commercial that ran by Colgate, the toothpaste company, stating that 4 out of 5 dentists recommend using Colgate, which sounds great. That sounds like, oh man, Colgate's a fantastic toothpaste that's like heads and shoulders above the rest of them. So it sounds like they're doing great, but they're not. Actually, that survey that they did was asking dentists to pick multiple toothpaste that they would recommend. So they might have picked Colgate. 4 out of 5 of them did pick Colgate, but they also might have picked Sensodyne or Crest or any other toothpaste company. So to say 4 out of 5 dentists recommend Colgate, the way that they're wording it makes it sound like 4 out of 5 dentists would only recommend using Colgate, that they don't, it's better than everything else. But in actuality, the way that they actually measured that was to just pick out of this list which you recommend, and 4 out of 5 of those dentists happen to pick Colgate as just one of the toothpastes they recommend. So that's kind of the idea of recognizing that statistics can be used to influence how people think. It's not just, it can be cut and dry, it can be very straight to the point, because data very much is most of the time. But also keep in mind in the back of your head that when you see public polls or see commercials or advertising using statistics, don't always take it at face value, because they could be doing some shady shit like this, where it's like, yeah, but not really. So it's going to benefit them. So there are 2 types of statistics. There are descriptive statistics and inferential statistics, both of which we're going to be covering in this class. The first of descriptive statistics is used to organize and summarize information. So oftentimes when we're analyzing data, there's a lot of stuff that we're looking at. And descriptive statistics kind of wraps it up in a pretty little bow and says, hey, instead of looking at these trillions of data points, I've summarized it with a mean or a standard deviation or something like that. Inferential statistics uses descriptive in the sense that it oftentimes things like average or mean and standard deviation are used to calculate certain inferentials. However, with inferential statistics, it's interpreting meaning. So it's providing us relationships or how these things are related to one another, as opposed to just saying the average something or other is 6 or something like that. So we're going to get into descriptive statistics first. Well, first off, data must be collected. Oftentimes these data are usually numeric. I will say data and data interchangeably, so just, yeah. But anyway, Oftentimes data can be measured through scores, like, oh, I'm going to give you a depression inventory scale and I'm going to see your measurement, your score on that. Measurements, different ways to measure things like, oh, your heart rate or your beats per minute or whatever the case may be, or observations. I'm going to observe people and count how many times they provide care for the homeless, or I'm going to count how many times they do nervous twitches or whatever. So data must be collected in order for us to have statistics to deal with in the first place. And as I mentioned briefly before, descriptive statistics takes this data and summarizes them. So you can have 100 people, you give 100 people this depression inventory, and you have scores for each individual person of 100. But instead of just like, oh, well, person 1 scored 7, person 2 scored 10, person 3 scored 12 or whatever, instead of doing that, descriptive statistics is, oh, of these 100 people, the average is 6.2 or something. So descriptive statistics makes it a lot easier for us as statisticians to just kind of get a brief glimpse of the data, a brief idea of how it kind of falls, as opposed to looking at all 100 cases or however many you have. So descriptive statistics is certainly vital in terms of reducing headaches. So I talked about how we can use statistics in any way we want, and I mentioned the egg and a TV personality. So obviously I'm talking about Jenner. So if we want to measure if people like Kylie Jenner or an egg more, we can ask people, which do you like more? So we can say on a scale of 1 to 10, 1 being not at all and 10 being with every fiber of my being, how much do you like Kylie Jenner? And like, oh, 4, I'm not really, she's whatever. Or on a scale of 1 to 10, how much do you like this egg? If we ask every person that question, or both of those questions, we ask 100 people on a scale of 1 to 10, how much do you like Kylie Jenner? On a scale of 1 to 10, how much do you like this egg? We collect that from 100 people. Statistically, we can determine, hey, more people like Kylie or more people like the egg, but that's more into inferential statistics. For right now, let's say we give 100 people these questions of how much you like Kylie and how much you like the egg, and the average out of 1 to 10, the average response for liking Kylie Jenner was 6.7, and the average amount for liking the egg was 7.8. Again, these averages are considered descriptive statistics. We're not really looking at each individual person of like, oh, person 1 likes Kylie at a 9 and the egg at a 7. Person 2 likes Kylie at a 1 and the egg at a 10 or whatever. It's just throwing them all together into one number that's easier to deal with than all 100 responses. So again, these are descriptive statistics. It really just briefly summarizes the data, gives us that description, and it's easier to handle. So descriptive statistics are just part of it. So we can only do so much with having means and reporting our data in tables to make it easier to read or understand. We also need to have inferential statistics. And this helps you answer your research question or address your hypothesis of, hey, who do people like more, Kylie Jenner or the egg? Descriptive statistics will just give us means. And sure, the mean for liking the egg was higher than Kylie Jenner for liking Kylie Jenner, but it's through inferential statistics that we determine, is this really the case? Or is this just a fluke? Is this just kind of just how these 100 people happen to respond? Or is this something that is more that we can generalize to the population, that people do actually like this egg more than they like Kylie Jenner? A quick note about the difference between inferential and descriptive statistics, at least one that I like to mention, is that with descriptive statistics, keep in mind its means and standard deviations, which we'll get into what a standard deviation is later, but it's basically describing the data. So that would be like if you were getting to know someone and their descriptive statistics, it's more surface level. So you see what people are wearing. You see a person wearing suspenders and a bluish designed shirt with, I think these are flowers. I'm not entirely sure what's on this shirt. You see short hair, you see, well, you can't see my legs, but I'm wearing black pants, whatever. Descriptive statistics is just kind of looking at people and seeing what they're wearing. Oh, they're wearing a red shirt with black pants and they're working at, well, okay, never mind. But okay, this is what they look like at the surface. Inferential statistics in statistics, that's getting into answering research questions, hypotheses. It's getting more into what the data is actually telling us about these different variables that we're looking at. So inferential statistics is getting to know someone. So yes, I'm wearing suspenders and a bluish flowery designed shirt with my short hair, but if you wanted to know me inferentially, that would be getting to know my personality. So am I an asshole? Am I kind to people? Do I, you know, what is my relationship with people like? How do I treat other people, etc.? That would be more inferential statistics. So that is kind of the quick and dirty, just kind of differentiation between descriptive and inferential statistics. Yes, descriptive statistics are still necessary. We still need to know the means and standard deviation. We still would appreciate to know what people look like on the surface or kind of their general demeanor on the surface. But in terms of the inferential aspect, that's kind of getting deeper and getting more into, okay, how are these related to each other? How big of an asshole is this person, etc. So with inferential statistics, the reason why it's called inferential statistics is because you infer things from the data that you have. So to infer something means to generalize. Now we have samples and we have populations. Typically, we're going to be dealing with samples. You know, if we're taking 100 people, that is a sample of the greater population. Now you can define your population as men and women. You can define it as college students, high school students, the elderly, people under the age of 25. You can really, your population is who you make it. Typically, when I'm dealing with research in, let's say I teach research methods and psychology here at State, typically our population that we're looking at is college students. So our population is all college students. However, the samples that we obtain are, you know, 100 college students from Fresno State, or, you know, 100 college students from the Central Valley area, whoever, you know, replies to your, whoever is able to participate in the study. But this, these inferential statistics is able to take this sample of 100 or 200 and infer or generalize this information we learned, like, oh, people like Kylie Jenner more than the egg. In this sample of 100 college students, we can infer that, oh, the population of college students in the United States tend to like Kylie Jenner more than the egg. That was our finding. So populations, the reason why statistics uses samples as opposed to populations, it's like, well, why couldn't we just take the population? That seems like it's easier. Then we know for sure what the population is saying, as opposed to, you know, just kind of inferring this information from our sample of X amount of people to everyone else. Why don't we just use the populations? Well, because that would be damn near impossible. Let's just stick with college students. Let's say that we're looking at college students as our population. And let's say we want to go about measuring every single college student. Well, okay, first off, let's make it easy. Let's just say college students in California, which is still hundreds of thousands of people. So I don't know the exact number, and oftentimes we don't have an exact number to our population because it's always changing. So for example, for college students, you have people who are incoming freshmen. So those are new college students. You have people that are, you know, in the midst of it. Are you counting graduate students? They're attending college. You need to define who it is you're looking at. But at the same time, it's going to take you a long time to get this survey to, do you like Kylie or this egg more? It's going to take you time to distribute that to every single college student in California. You need to get emails, you need to get, you know, some way to communicate with them. You need to have a list of who all the college students in California are, get their information, send it out to them. And then there's always the possibility that they're not going to see that email, or they're not going to give a shit and they're not going to fill out the survey. So if there's even one person missing from the population, you can't say you have a population. If your population is 1 million and you have 999,999 people, no, 999,999,999. Okay, so whatever. If you have one less than 1 million, that is still not considered an entire population. That's considered a sample, because that your whole population is not covered. And it's going to take time to get these people to send out response, to find everyone, send out the survey, get the responses back. And then by the time you get all this done, it could take a year, it could take 2 years. And then, hey, guess what? 2 years have passed. We have new incoming freshmen. We have college students that took your survey but have since graduated, so they're not college students anymore. Finding populations, measuring every single member of the population is way too time consuming, and it's too fluid of a population, of a group of people, to really say, oh, we'll have enough time to measure all of them. You'll need a lot of money and you'll need a lot of manpower to do that. Chances are you're not going to really have that to that extent. So we take samples and infer it to the population, long story short. So taking that Kylie and the egg example, we had our general means for it. So we had like 6.7 for Kylie and 7.4 for the egg, or exactly what the numbers were earlier. So if we want to see who college students like better, Jenner or the egg, again, like I mentioned, all college students would be the population. However, our sample is not containing every single population because, like I said, it's too time consuming, and that population is a fluid source. It's people are coming in, people are going out. It's just too hard to keep track of. So we take samples. And from that, we do some inferential statistics, in this case, an independent samples t-test, or a dependent samples t-test, actually. But we'll get into that later. But we do some inferential statistics, and we determine, oh, people do like the egg more than Kylie Jenner, or oh, people do like the Kylie Jenner more than the egg, or whatever it is our results are telling us. And we're able to infer that to the population of college students. But with inferential statistics, we're seeing, in this case, the comparison between liking Kylie Jenner, that variable, and liking the egg, and seeing which is more, who likes them more. And it's more than just looking at the means and saying, oh, wow, people like the egg more. We'll get into that as the semester goes on. So one way to kind of practice, I'm going to read these out loud and I'll give you guys a minute to respond. I'm going to explain them, but which is an inferential statistic and which is a descriptive statistic. So we have college students drink an average of 2.6 cups of coffee a day. And then we have Psych 42 has lower student engagement levels compared to Psych 10. So statistics has lower student engagement levels than Introduction to Psychology does. So take a moment and think about which one of these is descriptive statistics and which one of these is inferential statistics. You can go ahead and pause this video because I'm going to explain it right now. So again, descriptive statistics, typically just measuring the means and standard deviation. Inferential is looking at relationships between variables. So that first one, college students drank an average of 2.6 cups of coffee a day. Well, that's just, you know, taking college students, probably a sample of college students because we're inferring to the population. But we take we take a sample of 100 college students and we see that on average they drink 2.6 cups of coffee a day. Just that alone, just stating what their average number of cups of coffee they drink, that's just descriptive statistics. We're not talking about, oh, they drink more cups of coffee than they do tea or energy drinks in a day. It's just saying this is how many they drink. This is the average amount. We're not comparing it to anything else. It's just that and that alone. Now, the second one, how statistics classes has lower student engagement levels than Introduction to Psychology, that is defining a relationship. That's DTRing it. You see that there is Psych 42 has lower student engagement levels compared to Psych 10. So we see a relationship there that we can measure through inferential statistics. So that would be a description of inferential statistics, that Psych 42 has lower levels of student engagement levels compared to Psych 10. Excuse me. So now we use research methods and statistics. So all psychological research that is accredited and legitimate that you should actually listen to, and it's not pseudoscience, uses the scientific method or the research method. So there are 3 different research methods used in psychology and all behavioral sciences, but I'm going to focus on psychology. We have experimental, we have quasi-experimental, and we have correlational. So this is just how you set up your survey or set up your study. And there are different statistics that go into each of these types of research methods, but statistics is all used for this. So first, the experimental method. This is demonstrating causal relationships, how one is causing a change in the other. So to do this, you must manipulate variables in the experiment. This is known as the independent variable that's being manipulated. You have to include randomization, which means the people that are in the groups are randomly assigned to them. And you have to include a comparison or control group. So let's say that we had a study where I want to see how the environment of a classroom influences test scores. What I can do is the environment I'm going to manipulate. I'm going to have a classroom where it's super loud and disruptive. Maybe there's a band that's just playing, a one-man band that's just banging his bass drum in the middle of the class. And my participants, let's say it's 50 people, I'm asking those 50 people to sit in that loud classroom and take a statistics test. Then I have another group of students, 50 different students, and I put them in a quiet classroom, something you're more typically used to when it comes to taking a test. It's quiet, maybe the occasional ruffle of papers or the occasional sneeze where there's always one person who's like, bless you, and they always like whisper it. It's always like, ooh, you said something. But anyway, you have 50 different people and they're taking a test in a quiet condition. I have manipulated that. I have people, the manipulation is the test environment, the room in which they're testing in. It's really loud with the one-man band, or it's the typical quiet classroom. And that is how I've manipulated that variable in the experiment. Randomization would be of those 100 total people. Remember, I had 50 in each group, so 100 total people. I am randomly assigning them to be in either the loud condition or the quiet classroom condition. So maybe with each person who comes up to me saying, oh, I'd like to participate in your study, I flip a coin. And heads, you go to the loud classroom, tails, you go to the quiet classroom. I flip a coin and they get heads. It's like, okay, you're going to be going into this room. Next person comes up, flip a coin, it's tails. Okay, you're going to go in this other room, etc. Some sort of randomization to where it's not like the first 50 people that show up are going to be in the quiet condition and the last 50 that show up are going to be in the noisy condition. That's not randomization. That is not randomized. And we'll get more into the biases of that as we go on in the semester. And then including a comparison or control group. If you're going to be manipulating variables, you have to, have the control group of the quiet class where it's like, yeah, this is typically where we have how we take tests when we had face-to-face classes, a quiet room, relatively little noise other than, again, that shuffling of papers or, the occasional sneeze or cough here and there. And then we have the experimental condition or just another condition to compare it to, which is the loud one-man band banging on his bass drum. So like I said, there's an independent variable. This is the part that's being manipulated. So in this class, in this case that I mentioned earlier, the independent variable is classroom condition. So classroom environment. Are you in the loud environment or are you in the quiet environment? So participants are assigned to these groups randomly. They can be flipping a coin, etc. And then there's that control group. These are all things I've mentioned previously. So I have an example. This works better for in class, but I'll just kind of explain to you guys the idea. So I have an experiment here where there's a list of words. One is written in red font, one is written in black font. It's all the same words. So I have students, like half of the class will look at the list, the words in black, and look at them for about 30 seconds to a minute, and they'll have to recall as many as possible. So I'll show them the list for 30 seconds, and then I'll take it away and say, okay, now for those people who got to see the list, write down as many words as you remember. And then the other half of the class, I will show them the, so here's the black words. I'll let them look at that for 30 seconds and then turn it off and say, okay, write as many as you remember. And then I have the other half of the class look at the red words and then have them do the same thing. They'll have 30 seconds, turn off the screen, and then write down as many as you remember. So the dependent variable, I mentioned how independent variables are things that change. In that case, it was the color of the words. Everything's the same except for, did you have your words written in black ink or in black, or were they in red ink or just in red font, I should say. The dependent variable is what we're measuring across to compare the groups. So in our case, I wanted to look at the number of words that students correctly recalled. Words that weren't on the list, I'm not going to count as, you know, a correctly recalled word because wasn't on that list. But if the number that they get correct is the dependent variable. So the words are the same across each group. The only thing that changes is the color. I don't want to give one group a list of words and the other group a completely different list of words, because otherwise it'd be hard to compare the two. Otherwise, we have two things that changed, not just the font color, but the words themselves. Maybe one word list is just naturally easier to remember than another list. Well, why are we going to switch it up? We should only manipulate a difference between one thing, so that way we can say for certain, oh, you know, maybe more people recall words from the red list. Well, that's because of the change of font color. Red helped people remember more words. So as I said, the independent variable is the thing that changed, so that is the color of the words. Randomization occurred beforehand, so typically I put you guys in groups, and these groups are, excuse me, these groups are randomly assigned. I grab a random number generator, and I put you guys in groups that are completely random because I've used this random number generator. When I split the class in half, it's okay, this groups 1 through 3 and do the red words, and groups 4 through 6 do the black words, or what have you. The control in this experiment was the black list condition, because typically when we read things, books or, you know, articles or anything really, oftentimes the default font color is going to be black. So that we can kind of think of that as our control, and the red words are our experimental condition. So yeah. And like I mentioned before, the dependent variable, the thing we're comparing across these two groups, is the number of words recalled correctly. So maybe our descriptive statistics are saying, oh, the blacklist condition had an average of 7.2 words recalled correctly, and the red list condition had an average of 9.2 words recalled correctly. That's just descriptive statistics. But then getting into inferential statistics, we conduct the appropriate tests and we determine, oh, people who had access to the red words recalled more words on average than the black words. Hi, Amelia. Good job. Can you go in the living room, please, sweetie? No, Amelia, I need you to go in the living room. Good job. Can you go to the living room, please, sweetie? Amelia, please go to the living room. I'll talk to you later, okay, sweetie? Good job. That's how you spell your name, honey pie. Okay, can you close the door, sweetie? I love you. Okay. So, we talked about the experimental method, where we have the manipulation of variables, randomization of people in one condition or the other, and a control group. Now, the quasi-experimental method, the second of the three that we're going to discuss in terms of research methods in psychology, it's similar to what we do in experiments. However, with quasi-experiments, they meet one or both of the following conditions, where they either do not contain a manipulated independent variable or just a manipulated variable, or they lack a comparison or a control group. So as an example, if you're thinking, well, what the hell does that look like? When variables are not manipulated or can't be manipulated, it makes random assignment impossible. So to let you guys know, when I was writing my thesis, I was comparing online students and face-to-face students who were taking Psych 42. So this exact class that we're in right now, I was comparing those that were taking it in the traditional face-to-face setting and comparing it to those who were taking it online. What I did was I measured the student engagement between them two. But in terms of those lists of people who chose face-to-face and people who chose online, those were my two groups I was comparing to one another. Now, did I manipulate that? No, there was not random assignment to those conditions. People chose face-to-face classes or online classes on their own accord. Maybe they chose the face-to-face class because it worked with their schedule better, or they know they can't really do online. Maybe they chose online teaching because they couldn't, or an online class because they couldn't find any that fit their schedule, or they work or have kids and it's difficult to, be out of the house at certain points in time or whatever. But the point is, the reason why there was not random assignment is because to have there be random assignment in that situation, I would have had to be sitting next to all 222 of my participants as they were registering for classes. And they might have said, ooh, I think I'm going to do this 10 o'clock Monday, Wednesday class for statistics. Yeah, face-to-face, cool. I'd be like, I flipped a coin and you got tails. So that means you have to register for an online class. I've determined it, so you got to do it. And I did that for the 221 other people that I did. Now, obviously, I didn't do that. I just pretty much took the people who were in face-to-face and took the people who were in online classes, took those groups as is, and just compared those two. So I was dealing with a quasi-experiment because there was not random assignment to being either in a face-to-face or an online stats class. There wasn't really a way I could do that. It just wasn't going to happen. So it was a quasi-experiment. Another example is that gender cannot be manipulated by the researcher. So if we're comparing men, women, and people who classify themselves as either transgender or intersex or what have you, this is a little bit dated. I apologize for that, this PowerPoint here. But if I'm going to be comparing gender, I'm not assigning people a gender. I am not manipulating that variable. People will come in and say, oh, I am a man, or I'm a woman, or I'm a trans male, I'm a trans female, or I'm intersex, or what have you. The researcher isn't flipping a coin and saying, oh, you're going to be a trans male today, flip it. Oh, you're going to be a woman today. That's not how it works. You just come in with as you are. And with that, anytime that we're looking at gender in terms of research and psychology, oftentimes it's going to be a quasi-experiment. If we're comparing genders to one another, obviously it's just going to be what the participants that we have, the gender they come in with is the one that we're going to work with. We're not manipulating and assigning people to be in the male gender, the female gender, the trans male, the trans female gender, or the intersex gender. It doesn't work that way. It's just come as you are, as Kurt Cobain would say. Lastly, we have the correlational method. So we will say this multiple times in this class. If you don't remember anything from this class, remember that correlation does not imply causation. And also that Colgate was kind of shitty for saying 4 out of 5 dentists recommend them. But correlation does not imply causation. So I mentioned how before in experimental methods, we have manipulation of variables. How, oh, I'm going to show you guys the same list of words, but one of those words is going to be in black font, the other is going to be in red. I manipulated the color. Or, oh, I'm going to give 100 people a statistics test. 50 of them are going to take it in a loud condition where there's a drum banging, and the other 50 are going to take it in a quiet condition where you would typically take an exam. That is a manipulation of variables. Correlation does not have any manipulation of variables. It's pretty much just gathering data in whatever way it is that you're gathering the data. So since we're not manipulating anything as experimenters, as researchers, we cannot determine a cause and effect relationship with correlation like we can with an experiment, or even sometimes quasi-experiment. As an example, to give you guys an idea of what that would look like, so let's say you want to measure the relationship between self-esteem and the number of posts people have on Instagram in a week or something like that. That doesn't matter. But let's say we want to see the relationship between self-esteem and number of posts on Instagram. So you give people a self-esteem survey, maybe it's the Rosenberg self-esteem scale. You give them the survey, they fill it out, they give it back to you. And then you count how many times they've posted on Instagram. On their personal Instagram page, you count how many times they've posted something in the last week or what have you. The data that we have is going to be correlational, or the method we use to analyze this is going to be correlational. Either the more Instagram posts people tend to also have higher self-esteem, or the more Instagram posts people have, the lower their self-esteem tends to be. We can't say, oh, the higher the more Instagram posts you have, that causes you to have higher, or it causes you to have lower self-esteem. We can't use that C word when it comes to correlation. We have to say, oh, there tends to be an increase. It's always very like walking on eggshells when it comes to describing the relationship, because we can't say it causes it. The reason why is, hey, if we manipulated something, we can say, okay, everything else was the same, but since we manipulated this and there's a difference between these groups, it's because of the manipulation that these things are different. That makes sense. But when it comes to this, we didn't manipulate people's self-esteem. We just gave them this survey and told them to fill it out and give it back to us. We weren't like saying, you're a shitty person, take the self-esteem survey. Or you're the greatest person I've ever met in my entire life, take the self-esteem survey. We didn't manipulate it. We just said, here, fill this out. And then we counted the number of times they've posted on Instagram. Again, this kind of goes with that online and face-to-face class way of how we didn't manipulate that. We weren't with them in the week where we were observing their Instagram posts and saying, okay, you're going to have to post 3 times today, okay, because you're in our group of more Instagram posts, and so you need to post at least 3 times in this day. That didn't happen. We just simply counted how many they've had in the last week, or however we're going to break it down. We've just counted how many times they posted, and that's it. The researcher had nothing to do with it, hands off in terms of manipulation. It was just, I'm going to count how many posts you have, and I'm going to just see what your self-esteem score is. That's all we did. We didn't actually change anything. So here's another practice. I'm going to read these out loud, and just you can pause the video after I've read them, so then you can kind of think about it to determine which of these is using quasi-experimental, which is using true experimental or just experimental, and which is using correlational methods. So here, California raises the minimum wage while Nevada does not. Overall happiness of citizens is compared between states. The relationship between household income and GPA. And 40 people are assigned to shop for an hour at Walmart, and 40 different people are assigned to shop at Target for an hour. Patience is measured and compared between the 2 groups. So which of these is correlational, which of these is quasi-experimental, and which of these is just experimental? Pause. Okay, so I'm going to get into it now. So looking at this first one, California raises the minimum wage while Nevada does not. Overall happiness of citizens is compared between states. So you're comparing the happiness in citizens of California to the happiness of citizens in Nevada. So those are your 2 groups that you're looking at. Did you manipulate people to live in California? Did you get all however many millions of people combined live in each of these states? Did you take these, let's say it's 40 million people, I don't know, whatever. Did you take each one of these 40 million people and say, okay, you are going to be in California, flip a coin, you're going to be in Nevada, oh, you're going to be in Nevada, you're going to be in California? No, you didn't do that. You didn't randomly assign people to live in either California or Nevada. These are just the people that live there. These groups have already been predetermined, and it'd be near impossible to manipulate that aspect of, do you live in California or do you live in Nevada? So this first one is going to be a quasi-experiment, because there was not random assignment to groups. Again, our groups being Californians versus Nevadians. I don't know if that's a word, but people who live in California or people who live in Nevada. Nothing was manipulated there in terms of where do you live. Now the second one is looking at the relationship between household income and GPA. There's not a manipulation here. There is not a manipulation in terms of, okay, I'm going to manipulate how much you earn in your household, or I'm going to manipulate how well you do in school or how good your grades are. This is essentially, you can think of it as like, okay, well, I've given a survey to people, or just given them 2 questions. What's your household income? What's your GPA? People fill those out, give them back to you. You as the researcher, you didn't manipulate anything. You just said, okay, so this guy has a household income of, I don't know, with the 3 people in the house, it's 70,000, and this guy's GPA is, I don't know, 3.2. Oh, next person, you know, here's their household income, here's their GPA. You didn't manipulate anything. You just asked them to simply report that to you. So that would be a correlational design. Next one, 40 people are assigned to shop at Walmart for an hour. 40 different people are assigned to shop at Target for an hour. Just that alone, the fact that they are assigned to that condition should let you know that that is an experiment. When you have that random assignment, when 40 people are randomly assigned to shop at Walmart and 40 different people are assigned to shop at Target, you already have that idea of you have 80 people total, and maybe for each person in your pool, in your sample that comes up to you and saying, I'm ready for the experiment, you just flip a coin and say, okay, you're going to be going to Target today. Flip a coin, okay, you're going to go to Walmart today, or what have you. So, and it's a lot, I'm making it simple by having them come up to you and flip a coin, but essentially it's that same idea where every person in your sample of 80 in this particular example, each of those 80 people has the exact same probability of being in either the Walmart condition or the Target condition. It's just flip a coin 50-50. So that is statistics in a nutshell. If you have any questions, don't hesitate to ask me. You can send me an email or a message on Canvas, or again, you can come to my office hours, but just that is the statistics in a nutshell. So yeah, so welcome to the first week. So that's all I have for you. Like and subscribe, and I'll see you guys next time.